Welcome in this week Technical Tuesday with NXCam. It has been some time since I published last video, so here it is. Continuation of last episode, where I presented integrated simulation and verification in NX. I was focusing on simulating NC code on milling machines, so today I will focus on multitasking machines. With that being said, I will not wait any longer and start with first example. Here we have a post-processor and ISV kit for CTX Gamma 3000 TC. It has upper live B-axis, tailstock, and 2 steady rests. All of this is handled by post-processor and simulator. In this example, I have prepared several operations. Let's see what they do. First operation is facing. Notice how the head is oriented. Let's assume that I prefer to do this facing with tool in horizontal position. To achieve this, all I need is to change B-axis angle and rotate tool around its axis. In NX, it is called flip tool around holder. After this modification, you will see why it is important to use ISV. With tool oriented horizontal, it is clearly not enough space between workpiece and the tailstock. And ISV has detected a collision with B-axis head and the tailstock. To solve this problem, we need to retract the tailstock to its home position. This post-processor and ISV kit contains set of auxiliary operations which allows us to handle all devices which we can't handle with standard NX toolpaths. As you can see here, we have available operations to program tailstock positions, to open and close steady rest arms, and to move steady rests. Now let's make sure that facing operation will be collision-free. It will be, because tailstock was moved away at the beginning of the program. After that, we have a center drilling and outside diameter turning operations. To be able to turn this entire length, we will have to open a right steady rest, which will leave our part without enough support. So obviously, now we should support our part with tailstock. So I will add an operation for this. In my sample program, positioning steady rest was already done, so we can observe how it is programmed in NX and how it is being simulated. I also want to show you how easy it is to modify how turning operations will be executed. I mean tool orientation for turning. As you can see, here is material left, which couldn't be cut because of insert and holder shape. To clean this, I will just copy previous operation. I will change tool angle and I will flip it. This way I achieved correct tool orientation to clean this material. In this example, I showed you how you can control and simulate not only machining operations, but also all additional devices which complex mill turn machines can be equipped with. Let's move to second example. It is dual channel machine with upper live B-axis head, lower turret and two spindles. On this example, I will demonstrate another situation where you can expect collisions and how it is detected by ISV. I will also show you 3 ways to avoid this collision. Now I will run simulation of my sample operations. and you can see that tool change is causing a problem. Normally, post-processor outputs save retract automatically before tool change, but now I want to show you what options do we have to fix it manually. First and most obvious is to modify the toolpath. I will edit last operation before tool change and make departure move longer. I will run simulation again, and you can see that tool change is collision free now. I will undo toolpath modification to show you other options. Second way is to rearrange positions of tools in a turret. With an X, we do this just by drag and drop in Operation Navigator view. It was very simple, so let's see that it also solved the problem. Third approach may be not the most proper for simple tool change, but I would like to show you that with an XISV we can edit our NC code manually and simulate it again. To do this, I will post-process my operations normally. After that, I select Simulate Machine Code file from menu. This is dual channel machine, so I will put my NC code to second channel, which is the one used by lower turret. What I'm running now is simulation of external NC code file. And we see that it causes identical collision. Now I will locate this place in NC code and I will simply add save retract to NC code. With Okuma controller, we program G0 with some large value and the axis will travel just to its limit. I will run simulation again and my manual modification of NC code will be applied. Notice that we did all this inside NX, without searching for files on my local drive. You will find manual edits of NC code helpful in some unusual situations, which might be not handled by the post-processor. And what is most important, after your modifications, you can verify them again with ISV. With mill-turn machines, we can do some operations using different programming modes. As you can see here, I have very basic 3-axis milling operation. But in my case it is not possible due to small negative limit of x-axis. I will make a copy of this operation and I will simply attach it to different method. My post processor is configured this way that now it will output NC code for this operation using G137 function. In other controllers it might be called G12 or G12.1 or transmit. With this function active, machine will automatically convert all XYZ motions to X, Z and C motions. This way we will avoid X-axis hitting its limit. I will create one more copy of this operation and I will show you that we can achieve similar result with post-processor in case if such function is not available at the controller. To do this, I will use lock axis UDE. And now in NC code we have a X, Z, C motions. As you just saw, single milling toolpath can be executed in 3 different modes at the machine. On next example, you will see how post-processors with ISV can handle programming and simulating multi-channel machines. What you see on the left is an NX synchronization manager. It allows us to manage at what time and in which order NC code will be executed at the machine. This is an example of simple pinch turning operation. With last example, you can see that we can handle also turn mill machines. This is an example of milling machine with possibility to do also turning operations. Both processors and simulators for multitasking machines is very complex topic. That is why this episode of Technical Tuesday was a little longer than usually. I hope you enjoyed it, and I see you in next Technical Tuesday with an NCmatic.